In 2019, the Parker Solar Probe touched the Sun for the first time, officially becoming the fastest spacecraft ever made by humanity, flying at a speed of 430,000 kilometers per hour. And that's just in our solar system. There are billions of stars out there, and some of them are many times brighter than the Sun. Imagine that some crazy scientists have decided to send a spacecraft to one of those stars. So what would happen to it? What will this crazy spacecraft experience on its way to the stars? Let's find out. First, we need to agree on a few things. The spacecraft is made from materials that can withstand high temperatures and cosmic radiation. Otherwise, it would fall apart long before even leaving the solar system. Second, this spacecraft is fully fueled, meaning it has enough fuel to keep going until it reaches its destination. If it runs out of fuel on the way, then it will either fly past its target or simply fall into a star, which won't do us any good. And finally, the spacecraft has a powerful engine with near-perfect efficiency, so as not to waste precious fuel. So let's send our spacecraft on its journey. As soon as it leaves Earth's atmosphere, the spacecraft will encounter a stream of charged particles of the solar wind, and it will be instantly deflected from its course. That is, if the spacecraft didn't have a magnetic field, like the one that protects us from the Sun, and if it didn't move fast enough, our spacecraft is protected from the solar wind, and it's moving at a speed of 0.1 c, that is 30,000 kilometers per second. As the spacecraft approaches the Sun, it will begin to heat up due to friction with the solar wind. At a distance of 60 million kilometers from the Sun, the temperature will rise to 180 degrees Celsius. The spacecraft will reach speeds of over 70,000 kilometers per hour. These conditions are comparable to those on the surface of Mercury, the closest planet to the Sun. But the spacecraft won't stop there. They'll keep going at the same speed, passing Venus at a distance of 20 million kilometers. The temperature will rise to 370 degrees Celsius. And when the spacecraft approaches the Sun, strange things will start to happen. Since the spacecraft is traveling very fast, it will start to experience relativistic effects. For example, time on Earth will slow down relative to the time on the spacecraft. And the closer the spacecraft gets to the Sun, the slower time on Earth will go. At a distance of 10 million kilometers from the Sun, time on Earth will be 5 minutes slower than on the spacecraft. However, the most interesting thing is that on the spacecraft itself, time will pass differently depending on its orientation relative to the Sun. Due to the intense gravitational field of the Sun, time on the side facing the Sun will be even slower than on the far side. This effect is called gravitational time dilation. At a distance of 10 million kilometers from the Sun, the temperature will rise to almost 500 degrees Celsius. Our spacecraft will reach a speed of more than 100,000 kilometers per hour, which is 1/3 of the speed of light. At this point, we need to make a small digression. The fact is that according to Einstein's theory of relativity, the faster an object moves, the harder it is to actually push that object. That is, the faster the spacecraft moves, the harder it is for the Sun to slow it down. And the closer the spacecraft gets to the Sun, the stronger the gravitational field of the Sun, which means that the harder it is to accelerate the spacecraft. So it turns out that the closer the spacecraft gets to the Sun, the harder it is to move away from it. But at the same time, the stronger the gravitational pull. This means that the spacecraft won't be able to go around the Sun. It will fall to its surface. If our spacecraft is equipped with a camera, then in the last moments before falling onto the Sun, it will take pictures of unprecedented solar flares. Then it will fall to the surface of the Sun and burn to death. Or maybe it'll melt. Who knows? But all of this will happen at a speed of 0.33 c. At this point, we need to make another digression. We often think of the Sun as a giant ball of fire, but in reality, it's a giant ball of hot plasma. If the spacecraft falls into the Sun, it will likely behave like a meteor in Earth's atmosphere. It will heat up from friction with plasma and will burn up long before reaching the real surface of the Sun. But if it manages to reach the core of the Sun, Then it will find itself in a place where nuclear fusion occurs. It's unclear how the spacecraft will react to such a large amount of energy released during the fusion of hydrogen into helium. It's possible that the spacecraft will simply explode. But let's imagine that our spacecraft isn't destined for the Sun. Its trajectory lies beyond it. In this case, after passing Venus, it will continue on its journey through space at a speed of 0.33 c. After flying 10 billion kilometers, it will reach its destination, the star Alpha Centauri. It'll take about 12 years to travel this distance. But on Earth, time will pass much slower, about 10 minutes slower. That is, if a person sees the spacecraft off from Earth, then he will see that it takes 12 years to reach its destination. But for the crew of the spacecraft, only 11 years will pass. However, this is only true for the crew because the spacecraft is still moving incredibly fast relative to the star system Alpha Centauri. To slow down to a more comfortable speed, the spacecraft will need to brake for several years. In order for the spacecraft to completely stop relative to the star system in 100 years, it will need to travel another 990 billion kilometers. At a speed of 0.33 c, the spacecraft will need to travel 990 billion kilometers in 300 years. Therefore, the crew will need to wait for 300 years before they can land on their destination planet. But this doesn't mean that the spacecraft will completely stop. Even at a speed of 0.33 c, its kinetic energy will be colossal, so it's unlikely that any planet could stop it. And if our travelers manage to land on the planet, even if they manage to slow down, the impact would cause a catastrophe on a planetary scale. However, we shouldn't forget that even at a speed of 0.33 c, the spacecraft will constantly experience the gravitational pull of various space objects, planets, stars, and other celestial bodies. All this will affect the trajectory of the spacecraft, and it's highly unlikely that it will stay on a straight course. In addition, there's the issue of fuel. Even if the spacecraft uses nuclear fusion as its energy source, which is the same process that powers the Sun, then sooner or later, it will run out of fuel. Take, for example, the Voyager 1 probe, which was launched back in 1977. At first, it moved at a speed of 13.5 kilometers per second, but now it flies at a speed of less than 4.7 kilometers per second. And this is despite the fact that Voyager 1 doesn't travel at the speed of light. Sooner or later, the spacecraft will have to turn on its engines and slow down. And if this happens too far from the star system, then the spacecraft won't be able to land anywhere. All this means that the task of sending a spacecraft traveling at nearly the speed of light is almost impossible. But there are also some other problems. According to modern theories, nothing can travel faster than light. But even if we disregard this fact, then no spacecraft could travel at the speed of light. Light itself doesn't feel the force of gravity, but any spacecraft will. This means that any object that attempts to accelerate to the speed of light will inevitably slow down under the influence of a star's gravity. In addition, anything that accelerates to the speed of light will have infinite mass. An object with infinite mass can't exist. Therefore, traveling at the speed of light is impossible, both theoretically and practically. If we talk about the fastest spacecraft humanity has ever created, then the record holder is the Parker Solar Probe with a speed of 430,000 kilometers per hour. But what would happen if we sent this spacecraft on a journey through our solar system at the speed of light? It would take 238 days to travel the entire solar system at the speed of light, which is only 8 minutes longer than it takes light to make a round trip between the Earth and the Sun. At this speed, the spacecraft would whiz past all the planets in our solar system, including Pluto, and would leave our solar system in just a blink of an eye. It seems that humanity still has a long way to go before it can create a spacecraft capable of traveling at the speed of light. But who knows? Perhaps one day we'll be able to do it. Write in the comments if you know any other interesting facts about spaceships, and be sure to subscribe to the channel.